Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the June 2023 International A-Level Edexcel Pure Mathematics P4 paper. And this question here is all about vectors. And we're told that relative to a fixed origin O, the point A has position vector 4i plus 8j plus k. The point B has position vector 5i plus 6j plus 3k. The point P has position vector 2i minus 2j plus k. And there's a straight line that passes through A and B. Find a vector equation for the line L. So first of all, the position vector means from O to that point. So the position vector of A means the vector from O to A. So they gave us the vector from O to A, which I'm going to write in column vector form. 4, 8, 1. I like to write them in column vector form for my steps. And we can write them according to I, J, and K as they gave us. And we have the vector O to B, which is 5, 6, 3. 5, 6, 3. And we have the vector O to C, which is the vector 2, minus 2, negative 2, and 1. So those are the vectors for A, B, and C. The position vector of A, B, and C. It says a straight line L passes through A and B. Find the vector equation for L. Now, unlike M1 type of questions where you can kind of make for two-dimensional diagrams some kind of like a sketch that looks a bit realistic, here we have three-dimensional vectors and it's very difficult to make them look realistic. So you can just randomly put points anywhere you feel like for now, just to give you the idea. So we know that the straight line passes through A and B. So let's say this is the point O. Let's say this is the point A, and let's say this is the point B. Now there's a line that passes through A and B. Okay, let me just make that a bit thinner. Okay, so there's a line that passes through the point A and B. This is the line L. We'll call it the line L. We have the vector that takes us from O to A. That's the position vector of A. And we have the line that takes us from O to B. That's the position vector of line B. Now I don't know that this is okay. That's no problem. All right. So this is the vector from O to A, and this is the vector from O to B. O to A is 4, 8, 1, and O to B is 5, 6, 3. Okay. What we need to find is the vector equation for L. Now the vector equation of a straight line is given by two components. You have one of them, you have to have a point on the line, any point on the line. Okay, so basically you need to have the position vector of a point on the line. So we can use O to A or O to B, both of them would be fine. Okay, and the second thing we need to have is the direction of the line, the direction that the line is going in. So we can, for example, find the vector from A to B. If we find the vector from A to B, that will be, the direction on the line. We could also find B to A if we wanted to. No problem. Okay, so whichever one we want to do. So this is the point A, this is the point B. If I want to find, let's say we want to find the direction, for example, A to B. If I want to go from A to B, then I've got to go from A to O, and then from O to B. You'll notice that every time it's going to be basically, it's going to be the second one minus the first one, right? Because it's going to be O to B. If you go from A to O, it's like minus OA. It's like minus OA plus OB. Minus OA plus OB. All right, so you can think of it as, if you want, O to B minus O to A. Okay, O to B minus O to A. That'll give you the vector from A to B. Let's make some more space here so we can get a bit more chance to write things down properly. So we can say, therefore, the vector from A to B is going to be OB, which is 5, 6, 3, minus OA, which is 4, 8, 1. So 5 minus 4 is 1, 6 minus 8 is negative 2, 3 minus 1 is 2. So that's the vector from A to B. So we can say that the equation of the straight line R is given by a position on the line. So we can use OA or OB. So we can say 4H1 plus, and we can use a scalar factor. They didn't tell us a scalar, a scalar product. Oh, let's use lambda, scalar constant. You can use lambda, mu, A, S, S, T, whatever you want to use. We'll just call lambda, and then the direction, which is 1, -2, and 2. So this is a vector equation for line L. We could have used the other point. We could have used 5, 6, 3. I could have used this the other way around, -1, 2, -2, going in the opposite direction, as long as it's a straight line that passes through the point AB. So this is the vector equation of this line. It will tell you how to get to any point on the line that you want to. All right. So for example, if you want to find where you will be when lambda equals 3, for example, then you'd have to put 3 in here. So the first part will take you from here to there, and then 3 times this vector will take you somewhere along the line. It's going to be somewhere along the line because it's parallel to that direction. Okay, so that is the vector equation of the straight line, or a vector equation. As you notice, they'll say a vector equation because there's a few alternatives, as I mentioned. I don't have to use 481, I could use 563 because that's another point on the line. I don't have to use the direction going in one way, I could use it going the other way. So I could use this as -1, 2, or -1, 2, and -2. Or I could use this as 2, -4, and 4, some multiple of this. But normally you don't do that. But that's how you can write the equation of the line. All right, so then it says the point C lies on line L. So it lies on line L such that PC is perpendicular to L. Okay, so what's P? The point P. Hold on a second. I didn't read this properly, did I? It says the point P. That's OP equals. Now we don't know. We didn't use that, which is good. Then it says ABP, not C. All right, so we know OP is 2 - 2, 1. And we know that point C lies on the line L such that PC is perpendicular to the line L. Okay, so somewhere along the line, you have the point C. Okay, so we can draw it randomly anywhere. Have I got space here? I've got space here. Okay, so let me just take a quick snapshot of this. Okay. Now, so it says C lies on the line AB somewhere. Okay, C lies somewhere on this line. Let's say it lies over here. It didn't tell us exactly where, so I'll just put it anywhere. Now, we don't know the coordinates of C. We'll call that X, Y, Z. But P is such that P is in a place such that P to C is perpendicular to the line L. So, for example, if we place P over here, then this line that joins P to C is at right angles. So let me just adjust this a little bit so it looks like it's at right angles. Okay, so there's a point P, and that line has to be at 90 degrees to line 1. This is the main line. Okay, and here we know the vector from O to P. We know the vector from O to P. Okay, that's given to us already. The vector from O to P is given to us as we were given in the beginning, which I labeled C by mistake, 2, -2, 1. 2, -2, 1. Okay, so that's the vector from O to P. Okay, so now it says find the coordinates of the point C. So we know about C 2 things. We know that C lies on the line L. And the second thing we know is that the line C is such that P to C is perpendicular to the line L. Those are the two things that we know. Okay, so what we can do here is the following. We can form an equation from the fact that C lies on the line L. So we can say that there's going to be a value of lambda that takes us to C. Okay, so we can say that 481 plus lambda times 1 minus 2, 2 is equal to, I'm going to call it X, Y, Z. Okay, let's see C be the position vector of C be X, Y, Z. Okay, so that is one equation, or that's one piece of information we can use, and from this we can derive some equations. Let me just make this a bit clearer. 1, -2, and 2. Okay, so we have this to help us, and from this we can form three separate equations. We can say 4 plus lambda equals X, 8 minus 2 lambda equals Y, and 1 plus 2 lambda is equal to Z. So we have this, these three equations in X, Y, and Z with lambda, which is kind of derived from the fact that C lies on point L. So that's from the first thing. The second thing is PC is perpendicular to the line L. Okay, now we know when two vectors are perpendicular, their dot product is equal to 0. The scalar product is equal to 0. So to find the scalar product of two vectors, we need their directions. So we need the vector that takes us from P to C first. Okay, so we need to find the vector taking us from P to C. Okay, let's find out what that is. We're going to go from P to O plus O to C. So it's going to be the same as we discussed before. It's going to be O to C minus O to P. Okay, so you want to go from P to C minus OP plus OC. Okay, so that's going to be O to C, which is X, Y, Z, minus O to P, okay, which we know is 2 minus 2 and 1. That's going to give us X minus 2 and Y plus 2 and Z minus 1. So that is going to be the vector from P to C. Okay, and we know that it's perpendicular to the line L. Now it's perpendicular to the line L. When two vectors are perpendicular, then their dot product is equal to 0. If A is perpendicular to B, if vector A is perpendicular to B, then the dot product must be 0. So PC is perpendicular to L. So we can say the line L has a direction given by the direction part of its vector. This part of the vector tells us about the direction it's going in. This part doesn't tell us about it just tells us how to get to the line. What we're concerned about when vectors are perpendicular or parallel, or we're concerned about their directions or the angle between them, whatever, we consider the direction part of the vector only. So we have 1 minus 2, 2, that was the direction part of the vector L, times, we've got the dot product of that and X minus 2 and Y plus 2 and Z minus 1. We know that's equal to 0 if they are perpendicular. Okay, so we can just do the dot product. So you just multiply the I components together. So you have X minus 2, and then you're going to do plus minus 2 times Y plus 2 plus 2 times Z minus 1. And we know that's equal to 0. Okay, so this times this plus that times that plus that times that gives you 0. So that's going to give you X minus 2 minus 2Y minus 4 plus 2Z minus 2 is equal to 0. So you end up with X minus 2Y plus 2Z is, and you're going to have minus 2 and minus 4 and minus 1. That's going to be minus 8 equals 0. So we can say X minus 2Y plus 2Z is equal to 8. So now what we have these sets of equations that will help us. We have these equations here together with that, and I'm going to continue on the next page. Okay, so now to go on and solve this problem, okay, we want to solve these equations kind of simultaneously in a way. So what we can actually do here is we can, for example, take the x as 4 plus lambda and replace the x with it. So we have 4 plus lambda minus 2 times y is 8 minus 2 lambda. Okay, and then you have z is 1 plus 2 lambda, so plus 2 times 1 plus 2 lambda, and that's equal to 8. So when we solve this, for lambda, we find the position vector of C, which is what will help us. So we have 4 plus lambda minus 16 plus 4 lambda plus 2 plus 4 lambda equals 8. So we have 4 plus 1, that's 9 lambda. 4 plus 2, which is 6. 6 minus 16, which is negative 10, equals 8. So 9 lambda is equal to 18. So lambda comes out as a nice rounded number 2. So lambda is equal to 2. Okay, so we know that that's a position vector of C. C is going to be, and we've got the equation of the line, which is 481. In fact, C we can see from here. We can use these. That's the I component. This is like the I component. So you're going to have 4 plus 2 and 8 minus 2 times 2 and 1 plus 2 times 2. Those will be the vectors, or the position vector of C. So O to C is going to be 6, 8 minus 4, which is 4, 1 plus 4, which is 5. 6, 4, 5. That is the position vector of C. So the coordinates of C are 6, 4, 5. What did the question ask for? Part B, find the coordinates of C. So in the end, we should give it in this form, this coordinate form. That's how we should give the final answer in the end. So let's get rid of this box here. So we highlight the actual answer. So that's part C done, I think. Well, that's part B, actually. Find the position vector of C. Now we're going to go into part D. Part C, it says a point P dash is a reflection of P in the line L. Find the coordinates of P dash. Okay, so I have a copy of the diagram, which is related to what we have to deal with here. We have the line L, A, B, P, and C. Now, of course, this is a randomly drawn diagram. I don't actually know where these points are relative to each other in terms of a diagram like this is three-dimensional. So somebody might have drawn a diagram that looked completely different. The P might be over here, the A and B might be here. It doesn't really matter. Okay, just the principle matters now, that we want to find the reflection of P in the line L. So what do we know about reflection? Okay, the transformation of reflection. So a point which is reflected in the mirror line, and its distance from the mirror line, the image of the point that's reflected, its distance from the mirror line is the same distance as the object from the mirror line in like the perpendicular distance, you could say. So if I was to continue this line, if I was to continue the line PC, and I continued it on for the same distance that P is away from C, so say this is P dash, that this distance is the same as that distance, okay, then this would be the point where, you know, the image of P would be equidistant from C as P is from C on the other side and along a line which is at 90 degrees. So PC is at 90 degrees to the mirror line, and you know, so it's along this line. So basically from P to P dash is basically 2 times from C to P dash. It's twice that vector there, which is the same as 2 times P to C. 2 times P to C, right? Now, I need to find the position vector of P. That means the position of P relative to the origin. So it says find the coordinates of P. To find the coordinates of P, we need its position vector. Okay? To find the position vector of P dash, sorry, we need to find the vector O to P. Now, O to P can be found in a number of ways. We can find O to P dash, sorry, can be found in a number of ways. We can find O to P, which we know already, and then 2 times P to C. Or we can find what O to C is. And then we can just do C to P dash. All right, either of them are fine. We know O to C already. We found that. We worked that in the question. Maybe O to P would be better to use because it's something that was given to us in the question. So it's probably better to use O to P, to be honest. Okay, because we had to calculate O to C. So we could do that. We can say from O to P plus 2 times P to C. Okay, we already used P to C. Now, what was P to C? Well, did we find out what it was? I don't think we finished finding out what it was. We didn't need to find exactly what it was. We just needed to know that it was perpendicular. So we found P to C was this: x minus 2, y plus 2, z minus 1. So let me just write down what P to C actually is. Okay, we worked out over here. So P to C, let's see, x minus 1, y plus 2, and z minus 1. So we have P to C was x minus 1, y plus 2, and z minus 1. Was that right? X minus 2, y plus 2, z minus 1. X minus 2, y plus 2. X minus 2, y plus 2. So that should be a minus here. X minus 2, y plus 2, and z minus 1. Okay, good. Right, that's P to C. So we found, did we find the values of x, y, and z? We did. X was 6, y was 4, and z was 5. So therefore we can say the vector from P to C is going to be, I can write this down here actually. I can take this down here. Let's take it down here so we can. So P to C is basically going to be the coordinates of x, y, z, which was 6, 4, 5. So it's going to be 6 minus 2, and y, which is 4 plus 2, and z, which is 5 minus 1. So P to C is going to be 4, 6, 4. 4, 6, 4. Okay, so that's the vector from P to C. So therefore we can say that the coordinates of P, or we can say O to P dash, the position vector of P dash is going to be O to P, which is 2 minus 2, 1, plus 2 times P to C, 2 times 4, 6, 4. Okay, so you're going to have 2 plus 8, which is 10, minus 2 plus 12, which is also 10, and 1 plus 8, which is 9. Okay, that's O to P dash. So O to P is 2 minus 2, 1. Let me just confirm that in case we did that wrong. O to P is 2 minus 2, 1. That's right. Okay, we were given that already. And P to P dash is going to be 2 times P to C. So 2 times 4, 6, 4. Okay, so 10, 10, 9 is the answer for that one. However, we have to be careful not to lose marks. Possibly you might lose marks. Sometimes they're a bit lenient, but it says coordinates. So technically we should give the answer not in position vector form, but in coordinate form. So you can say P dash has coordinates 10, 10, 9. If it says find the position vector, give your answer in this form. It says find the coordinates, give it in coordinate form. Remember, coordinate form, this is like how to get from the origin to the point. 10 along the x, 10 along the y, 9 along the z. Okay, now then it says hence find P to P dash magnitude, giving the answer as a simplified third. So basically the magnitude of P to P dash is going to be 2 times the magnitude of P to C, which is 2 times, I'm going to have the square root of 4 squared plus 6 squared plus 4 squared. Okay, so it's going to be 2 times, that's going to be 16 plus 16, which is 32. 32 plus 36. 32 plus 36, that's 68. 2 times root 68. Let's just make sure of that in case I did some silly error there. So we have the square root of 4 squared plus 6 squared plus 4 squared. Okay, that gives us 2 root 17. So we're going to have 4 times root 17. Okay, because this is going to be 2 times 2 root 17, which is 4 root 17. This is in exact form. Okay, it says in exact as a simplified surd. So it's 4 times the square root of 17. That's the magnitude of p to p dash. Okay, and that concludes this question. Question number 4, I think it is, from the June 2023 Pure Mathematics P4 paper. This question all about vectors. Okay, so let's just do a little summary. All right, finding the vector equation of a line requires 2 things. It requires a point on the line, the position vector of a point on the line, and the direction that the line is moving in, the direction of the line. Just like y equals mx plus c, similar kind of cases. C is a point on the line, point where it passes through the y-axis, and the direction of the line is the gradient, basically. So a similar kind of idea to that. So here we have 2 points on the line we can use, A and B. So I could use either of them, but I have to find the direction from A to B. Remember, the direction from A to B is like the direction is, it's all related to the origin. So you want to go from A to B, the position vector of A means from O to A. So you got to go from A to O and then from O to B, which is the same thing as saying OB minus OA. Okay, and that gives you the direction of the line, and then you put it together in this equation. Okay, R equals, that's the equation of the line, equals 481, the position of a point on the line, plus lambda, some scalar parameter, times the vector representing the direction of the line. And then secondly, we had to, we knew that there's a point C lying on the line such that PC is perpendicular to the line. And we knew the coordinates of P. We don't know the coordinates of C. We have to find it. So we know 2 things about the point C. One of them is that it lies on the line, so it satisfies the equation of the line. That's how we form these equations. Secondly, we knew that the vector from P to C and the direction of the line are perpendicular. The directions, we choose the direction of the line when we're thinking about, whether it's perpendicular or whatever. We think about the direction part of the line. That's what we use for the scalar product, because we know that the scalar product must be equal to 0 if they are perpendicular to each other. So P to C, okay, we don't know what it is, but we can write it in terms of x, y, and z. We call the coordinates of C x, y, z. Okay, and then we used that, that's O to C minus O to P is a vector from P to C. So x minus 2, y plus 2, z minus 1. That's the vector representing P to C in terms of x, y, and z. And that vector P to C multiplied by the direction of the line must give you 0 as a dot product. So that gave us these equations here, which we then solved together. All right, so we were able to use these equations here, replacing the x in this equation with 4 plus lambda, the y with 8 minus 2 lambda, and the z with 1 plus 2 lambda, and equating that to 8. And that's what we did in part, this part, the second, just continuation of that. That's exactly what we did. And we found the value of lambda at which the point C is, and then we replaced that into the equation. Basically what we had, that's the x coordinate, the y, and the z coordinate of the point C, and we found the coordinates of the point C. And then the rest of it, we have to just deal with this geometry stuff. So that's some of the main points of how we tackle that question. They are very, very much like repeating every year the same type of question, especially these first few. The last part, the geometry part, can vary depending on what geometrical concept they're trying to test you on, but the most of them are like IGCSE type of concepts. But you have to just relate it to the vectors, that's all. All right, so if you would like to see other questions from this paper, then click on the link at the top here. If you would like to see links to the topic of vectors from P4, click on the link over here. You want to subscribe to the channel, click on this link. You want to watch a video that tells you how to find my topic index PDF forms where you can links to different things that you might need. Click on that video there. It will show you how to find those things. Thank you for watching, and see you soon.